You are sitting in an exam, staring down a sequence of numbers like this. The values jump up and drop down without any obvious logic. Trying to guess the pattern by simply staring at it burns the clock. Every minute you spend wondering if the list is arithmetic, geometric, or quadratic is a minute that costs you points on the test. We can eliminate guessing entirely. A 5-step elimination checklist successfully identifies any sequence every time. To use it, you only need a calculator and an understanding of 2 symbols: TN, which asks you to find a specific individual term in a list, and SN, which asks you to calculate the total sum of those terms. By the end of this tutorial, you will no longer rely on simple intuition to solve these exam problems. You will rely on a rapid, airtight process of deduction. Step 1. Look at the punctuation. Before you do any math, check how the numbers are separated from each other. Semicolons tell you this is a sequence. Plus signs, or sigma, mean a series, a total sum. Textbooks label a sequence RY and a series RX. Rule: if asked for the next term, never calculate a sum. Step 2. Your first mathematical test is always to check for a constant first difference. Subtract term 1 from term 2, then term 2 from term 3. If that subtraction gives the exact same number every time, it's an arithmetic sequence. Now, safely apply this exact formula to find future terms. But students fall into the doubling trap. Seeing a 4 followed by an 8, your brain assumes multiplying by 2. Testing only 2 terms hides the truth. Subtracting 8 from 12 gives 4. The pattern is a constant difference of plus 4, not multiplication. Surface-level observation will deceive you. Systematic subtraction across at least 3 terms is your only reliable first step. Step 3 applies when your first row of subtraction does not match. Testing this sequence, first differences are 3, 5, 7. They fail to match. Subtract those unmatched differences. 5 minus 3 is 2. 7 minus 5 is 2. This deeper, constant second difference officially confirms a quadratic sequence. Apply the formula with the n-squared term. But what happens when the first and second subtraction tests fail completely? That brings us to step 4. Switch operations. To test for a geometric sequence, divide term 2 by term 1, then divide term 3 by term 2. A constant result from this division confirms a geometric sequence with a constant ratio r. Apply the formula featuring an exponent. Standard sequences are built on layers of basic arithmetic. If subtraction fails to identify the relationship, division becomes the primary tool. Step 5 is the lifesaver protocol. You use this when subtraction and division tests all yield chaotic results. This is a mixed sequence, designed to confuse you. To solve it, isolate only the numbers in odd-numbered positions. This reveals a simple arithmetic pattern, adding 2. Next, isolate the remaining even-numbered positions. This reveals the hidden secondary sequence, which is geometric, multiplying by 3. You must treat these extracted patterns as completely separate math problems. If a question asks for a total sum, calculate the arithmetic sum, calculate the geometric sum, and add your final totals together. What appears as chaotic data is often just simple, familiar patterns woven together. It requires calm separation rather than panic. Here is your completed roadmap for any exam question. Check your symbols, test the first difference, check the second difference, test the ratio, and apply the mixed splitting technique if needed. Let's run a rapid-fire test. Identify this sequence. The answer is arithmetic, or reckon-kundik. Subtracting term 1 from term 2 yields a constant difference of positive 5. Take a screenshot of this checklist right now. Then, apply it immediately to the practice problems linked in the description below. Consistent performance in these exams depends on executing a systematic process of elimination.